I concluded the introduction by saying that Mexico's Juliaco Pyramid was actually an equation in spherical mathematics. And I made this determination despite the fact that this monument is not yet fully excavated. It has a distinction shared by very few ancient pyramids. It reached us with its base intact. The lower 33 feet of this structure was encased in a lava flow from a nearby volcano a little over 2,000 years ago, at which time the pyramid was already very ancient. Accordingly, we do have an inside date for that which follows. Spherical math from before the time of Christ, and Western style at that. Why hasn't someone noticed this before? Because we look at these structures through our eyes, not theirs. They handled math differently than we do. They committed mathematical law to geodetics, a methodology we're not familiar with. Hence, when our experts drew their conclusions for Juliaco, it became a cult temple of some sort, and we wrote it into history as such. Problem solved, case closed. Now don't misunderstand, please. There's nothing wrong with the way we do math. After all, it was good enough to take us to the moon and back. The math involved with that is virtually unreadable. In layman's terms, it would be like trying to hit a falling penny with a .22 rifle at a half-mile distance. Not easily done. Our modern game rules for math are very simple. It is based either on the constants of geodetic form, the 360-degree circle, 720-degree tetrahedron, 1080-degree pyramid, 2160-degree cube, and similar geometrics. Or the pi ratio. And, of course, ordinary numbers. These are our constants. But within these constants are a plethora of other constants. For example, if we multiply constant pi and constant 360, we get 1130.9733. We don't recognize the number, but it is another constant simply because it is the product of two other known constants. Constant to constant will always result in another constant. It's unavoidable. But not being used to recognizing constants which derive from the multiplying or dividing of two or more constants, when we look at something like Juliaco, all we see is four 360-degree circles. It fails to register. I mean, look at it. Can you see formulas here toward spherical computations? No, of course you can't. We do not reason our math as these people did, nor will we ever, unless we learn to think as they did, to see the law as they did. As good as we are with math, we are actually running in low gear. Math has a second gear, a third, and even overdrive, levels we have not yet achieved. But how does one look for these higher speeds when the best tools we have are those which hold us in low gear? It means starting over. Forget everything we know about math, except the constants, and go back to square one. Take the numbers and constants, mix them up, run them through the mill again, and look for new constants. Things we might have missed the first time around. Math is a rigid realm. Its laws are firm, at least to our way of thinking. But that doesn't mean that other deliveries are not possible. To us, the common circle exists to specific proportions. We see a circle, we've just got to measure it. We must have its radius, diameter, circumference, area, and so on. But suppose its measurements are not important. Suppose the language of the circle is the same from one to another, and irregardless of their measurements. These would be circles involving the so-called radian. In that consciousness, all circles have 360 degrees of arc. Their radians, obtained by dividing 360 by double pi, would always be exactly 57.2957 degrees. And it would make absolutely no difference what the circle's proportions actually are, whether 10 feet wide, 100, or even 1,000. It's a 360-degree circle, and its radius, the radian, will always be 57.295 degrees. End of matter. If these ancient builders thought in such terms, then we will never answer Juliaco by measuring it. Measurements would be irrelevant. So what is Juliaco's communication to us? What did its builders know that we do not? How are we to see through their eyes? We have already substantiated at Stonehenge that they knew and used the very same 360-degree reasoning system that we do when dealing with circles. And they certainly knew our base 10 system. And they knew the pi ratio inside out, as I will show in a separate segment later on. And given the fact that the Great Pyramid, the tallest one ever built, shows it to us so abundantly, is it not possible, even likely, that their intent was that we simply apply the pi ratio to whatever we see in their matrix, no matter where it happens to be on Earth? It does present a possible decoding plan, doesn't it? Shall we test it on Juliaco? To our mind, a circle infers pi. And here on Juliaco we see 4 circles. Could that mean 4 pi? Let's divide the 360-degree form of Juliaco by 4 pi. Their logic lies exposed after 2,000 plus years of silence. What is it? Well, of course you don't recognize it. It's doubtful that very many professional mathematicians will recognize it because they're not used to working with it. But 28.64788 is exactly 1/2 of the 57.2957 radian. Okay, fine. But what are we to do with it? Give it back to 360. The answer is also a mathematical constant, even though we're not used to looking at it. It is, in fact, the area of any 360-degree circle. Using our time-honored formula for finding the area of a circle, R is the radian, we square it, we get this. The formula for the area of a circle is radius squared times pi equals area. See? Same product. But the two formulas were different, weren't they? In our logic, we square the radian and multiply by pi. But in their primitive logic, all they did was to multiply the 360-degree circle by 1/2 the radian. No pi in their formula at all. The area of the 360-degree circle, and without regard to its actual measurements. And that's not all it is. It is also the grid longitude of the Juliaco, 130 degrees, 19 minutes, and 04.1754 seconds to the west of Giza. Juliaco's basic message, then, is the generic circle. Grid latitude 360. Grid longitude, the area of the 360-degree circle. And grid vector, 1/2 of the radian. an equation. Have we solved the puzzle? No. What we have so far is just the introduction. We still have those 4 terraces to explain. Never leave until the work is finished. I said earlier that Juliaco is an equation in spherical math, but it's unlike anything we have ever seen. It's a whole new ballgame. When we work with circles and spheres, we rely on 3 time-honored formulas. The first yields the area of a circle. In the 360-degree mode, that would become 10,313.24 square degrees. This one finds us the surface area of a sphere. For the 360-degree sphere, it finds 41,252.96 square degrees. And our formula for determining the volume of a sphere. For the 360-degree sphere, 787,873.52 cubic degrees. Three separate formulas. And just look how often we have to call upon the pi ratio, like it's some kind of a crutch. Well, we all know what crutches are for, but to ancient thought they were things to be rid of. This is how they did it in pre-Hispanic times. And Juliaco explains the formula to us step by step. 4 terraces, 360-degree circles, vector 1/2 the radian. Result is the surface area of the sphere, 41,252.96. Divide that by the 4 terraces, you get the area of the circle. Multiply it by 1/3 of the radian, you get the volume of the sphere. What tells us 1/3 of the radian at Juliaco? It's obvious. Look how the terraces are arranged. The upper terrace is set back well clear of the perimeter, a much smaller terrace. One small terrace over 3 large terraces. That's 1/3, isn't it? 1/3. And since we already know that Juliaco is a radian-based structure, the connection is obvious. 1/3 of the radian. As I said, Juliaco is a formula in circular and spherical math, and in one fell swoop it obsoletes all 3 of our time-honored formulas in that realm. A single, all-encompassing formula, and one which ignores our favorite crutch, the pi ratio. And history calls these people primitive? Never call primitive primitive without taking a good long look in a mirror. It just might backfire. Is this an entirely pre-Hispanic thing we see at Juliaco? No, it enjoyed a global application. Archaeologists don't pay a lot of attention to the smaller pyramids at Giza, but they too play in the matrix. As we see now, finally, at the southern base of the Mycerinus are the 3 we call pyramids number 7, 8, and 9, resting silently on a parallel of latitude which answers the surface area of the 360-degree sphere. Radian-based mathematics, not pi. That's what this matrix was all about. Now, we begin to see it through their eyes.